Lesson 2. Functions, Polynomials, and Quadratics. In this lesson, we will examine functions, polynomials, and quadratic equations. First, it is important to understand function mappings. A function like f of x equals x squared is many-one because different inputs can produce the same output, such as 2 and -2 both squaring to 4. When evaluating composite functions, always work from the inside out. For polynomials, the remainder and factor theorems are essential tools. The remainder theorem states that when a polynomial is divided by a linear term, like x minus 1, the remainder is simply the function evaluated at 1. If that remainder is 0, the factor theorem tells us the linear term is a factor of the polynomial. We can also simplify complex rational functions using partial fractions. Depending on the denominator, you might set up fractions with constant numerators, like a over x plus 1 and b over x plus 2. If there is a squared factor in the denominator, you must include terms for both the single and squared versions. Finally, let us discuss quadratics. You can solve them by factorizing or using the quadratic formula. The discriminant, calculated as b squared minus 4ac, tells us about the roots. For instance, a negative discriminant means the equation has no real roots. You can also find the minimum value of a quadratic by completing the square. Furthermore, if you know the roots alpha and beta, you can find their sum and product directly from the equation's coefficients, which allows you to evaluate expressions like alpha squared plus beta squared, or even form entirely new equations based on those roots.